All right, this is Math 209, Week 2. This is Section 7.2. Now we're dividing rational expressions. So when we are dividing fractions, the thing you have to remember about dividing fractions, and I'm going to move over here, is back in, let's say 6th grade, the idea for dividing fractions, let's say you had 5/6 divided by, 7/9, okay? So what you need to remember is when you are dividing fractions, this first fraction stays the same, so that's 5/6, and then this division symbol turns to a multiplication symbol, and then this last fraction always is the reciprocal. It flips over on its head. So the 7 over the 9 becomes 9 over 7. And then you are supposed to look for common factors. And in this case, 6 can become 2 times 3, and 9 can become 3 times 3. And then there is our common factor. 3 and 3, they cancel out, leaving us with basically what becomes 5 over 2, because this is 5 over 2, times 3 over 7, which is equal to 15 over 14. So I didn't need this. 15 over 14. So the big key is the first fraction stays the same. Let's do it in purple. The first fraction stays the same. The division turns to multiplication. And the second fraction does a flippy flip, all right? And that is the big key thing. Now, the idea is it's going to be the exact same set of rules when we are doing algebra, all right? So what do we have? We have 2 over 7x divided by x plus 7 over 7x. And so what does that mean? It means, well, the first fraction stays the same. The division symbol becomes a multiplication symbol. And then the second fraction flips. So you get 7x over x plus 7. And now we can see that we have a common factor. We've got 7x over 7x. And that, of course, equals 1 whole. So our final answer, so this becomes 2 times 1, which is 2. And then down here, we've got 1 times x plus 7, so that's just x plus 7. And that is your answer. All right, so now we are going to divide and simplify to lowest terms. So again, you remember, we're going to start with x minus 8 over 3x divided by, then we have 8 minus x over 6x. And the key that I want you to recognize is that x minus 8 and 8 minus x are not the same thing. So, but when we are dividing, we know that the first fraction stays the same, so that becomes x minus 8 over 3x. And then we know the division symbol becomes a multiplication symbol, and the second fraction flips over, so you get 6x over 8 minus x. All right, and here's why you need to know that x minus 8, 8 minus x are not the same, because otherwise we would be able to cross them off or cancel them out, but they're not the same, so we cannot cancel them out. But I do want us to notice that 6x can be thought of as 2 times 3 times x. So I've kind of replaced the 6x with the expanded form of it. And that by doing that, it allows us to see that we have 3x and 3x. That's a common factor. Technically, it's 3 and 3 cancel out, and then the x and the x cancel out, or you could just kind of lump it all in one step. It's up to you. And then what do we end up with? Well, technically, our first fraction here is x minus 8 over 1 times, and then our second fraction is 2 over 8 minus x. All right, and now the directions, by the way, said for us to type our answer in factored form. So what does that mean? That means we're not actually, ordinarily we would multiply. At this point we would multiply straight across if this was like 6th grade math. But they don't want us to actually multiply. So x minus 8 times 2, instead of actually multiplying it out, we're just going to leave it as a multiplication problem. 2 times x minus 8 over. And then down here, 1 times 8 minus x, well, that just stays 8 minus x because multiplying by 1 doesn't change your value. And so that is our answer right there. All right, more of the same. We're going to divide and simplify. And so we are going to start by copying the problem z plus 8 over z plus 4 divided by, and then we've got z plus 8 over z minus 1. And so what's the rules for division? Well, the rule for division is the first fraction stays the same, z plus 8 over z plus 4, and then that division symbol becomes a multiplication symbol, and then this fraction flips over, so we end up with z minus 1 over z plus 8. And now we're going to look for common factors, and we see that z plus 8 and z plus 8, there's our common factor, and so that they cancel out, leaving us with 1s. So technically, this becomes 1 over z plus 4 times z minus 1 over 1. And then when we multiply straight across, all right, multiplying by 1 doesn't change the value at all, so we don't even have to worry about writing it. So it's z minus 1 over z plus 4. All right, so they're getting just a little bit more complicated, but not really, not a whole heck of a lot. So this is 3y plus 7 over 9y plus 2 divided by 3y plus 7 over y plus 5. All right, so what's the rule for division? Well, the rule for division is that first fraction stays the same, so you got 3y plus 7 over 9y plus 2. The division symbol becomes a multiplication symbol. And then you've got this fraction flips over, so you end up with y plus 5 over 3y plus 7. And now we're looking for common factors, and sure enough, we see that 3y plus 7 and 3y plus 7 are common factors. We have no other common factors, and so technically I'm going to try and shrink and condense a step. So that's a 1 and that's a 1. So now we have 1 times y plus 5, so that's just y plus 5 over. And then down here we have 1 times 9y plus 2, so that's just 9y plus 2. And there is our answer. So we've got this fraction, and we're supposed to, this division problem, and we're going to divide. But the idea is, to divide, first thing we need to do is we need to take that problem and rewrite it as a multiplication problem. So remember, the first fraction stays the same. The division symbol becomes a multiplication symbol, and then our second fraction becomes 8 over t plus 5. All right, so now what we need to do is we need to factor anything that could be factored, because right now I see nothing that can simplify. This cannot simplify because they're not the same. This is a minus 25, this is a plus 25. Now I happen to notice that this is a difference of squares. So I'm going to go way over here on our scratch paper, and we know that t squared minus 25 can be factored using the box, and we know that t squared goes here, the minus 25 goes here. So, and then we know that t and t go there. We know that 5 and 5 go there, which makes this 5t and this 5t. But we know that these two internal terms have to cancel out because we don't have it in our original expression. So that makes this one a negative 5t, which makes that a negative 5, and makes this a positive 5t, and makes this a positive 5. So this really ends up being t plus 5 times t minus 5. So we're going to go back over here, and I'm going to rewrite this first expression as t plus 5 times t minus 5 over. Now, believe it or not, t squared plus 25 cannot be factored. It's got to stay there. It's got to stay the same. And then 8, well, technically 8 could have been rewritten as 2 times 2 times 2, but nothing's going to cancel, so it doesn't matter. And then we have t plus 5. So now we're going to look for a common factor. Do we have any common factors? Darn right we do. We have a t plus 5 and a t plus 5. And nothing else cancels. So what do we end up with? Well, we end up with this times this. So that's 8 times t minus 5 over. And then our denominator is just t squared plus 25. And nothing else cancels. So that is our final answer. All right, more of the same. The fractions are getting uglier, but we still have the same basic idea. So we're going to copy the problem down. And then we know that that first fraction stays the same. So that becomes 3x squared minus 9x over 6x minus 1. We know the division symbol becomes a multiplication symbol. And we know that second fraction flips over. 6x minus 1 over x minus 3. All right, and then so, oops, there we go. And so now what we need to do is we need to do some factoring. And I'm going to speed things along just a little bit by, I'm going to do some of the factoring in my head. If you're not sure about the factoring, what I want you to do is pause the video and look back to see what I did to make sure you understand how I got what I got. Now, this term right here, I see that we have common factors of 3 in both terms and a common factor of x in both terms. So I am going to factor out a 3x, which means from our first term, we are left with an x minus, and our second term, if I take out a 3 and an x, I'm left with a 3. And so this expression right here factors to be 3x times x minus 3. And then the 6x minus 1 cannot be factored at all, times. And then over here, the 6x minus 1 cannot be factored at all. And then the x minus 3 cannot be factored at all. Now we're going to look, now that everything's factored, we're going to look for common factors. And sure enough, we see that x minus 3 over x minus 3, that equals 1. And then we see that 6x minus 1 and 6x minus 1 is equal to 1. And so this whole thing is equal to 1. This whole thing is equal to 1. This guy is equal to 1. And this guy is equal to 1. So what do we end up with? Well, in the top, you get 3x times 1 times 1. So the numerator just is 3x. And then the denominator, you get 1 times 1, which is 1. So really, our answer is 3x. So this huge expression right here is equal to 3x. One more, only this time the fraction is really ugly, but the idea is all the exact same. So we're going to start by rewriting this as a multiplication problem. So you get x minus 3y over x squared plus 6xy plus 9y squared. So that's the same fraction. This division becomes multiplication, and our second fraction flips over. Now I'm going to kind of expand it a little bit. So instead of saying x plus 3y squared, I'm actually going to put x plus 3y times x plus 3y over 1. So we have some factoring that needs to happen. And so what we're going to do is we're going to take this term right here and we need to factor it. So what does that mean? It means we're going to do the x squared plus 6xy plus 9y squared. Okay, so it means we're going to go over here and we've got to use that box method. So x squared plus 6xy plus 9y squared. And so we're going to do our box. Here's our box, and we know that x squared goes here. We know positive 9y squared goes there, which makes this x and x. That makes this 3y and 3y. And if we multiply our internal terms, so you get 3xy, you get 3xy. And sure enough, this is exactly, if this is positive and this is positive, that gives us the middle term that we want. So that makes it plus 3y and makes that plus 3y. So this equals x plus 3y times x plus 3y. All right, so that's important. So when we go back over here, we know that, let me scooch over here. So this is equal to, so the numerator is the same. That doesn't change. But down here, this term we just factored, that equals x plus 3y times x plus 3y. All right, do you understand how we go from here to here? And then this time sign stays the same. And then the second fraction stays the same because I already factored it. X plus 3y times x plus 3y over 1. All right, and so now, boy, what a big old problem. Now the thing that's important to notice is that x minus 3y and x plus 3y do not factor. They do not, they're not the same factor. They do not cancel out. But if we look diagonally, we do have a lot of stuff that can cross cancel. We see that x plus 3y cancels with x plus 3y. X plus 3y cancels with x plus 3y. And so what do we end up with? Well, this ends up with being 1. This ends up being 1. This is 1, and this is 1. And so what do we end up with? We end up with, oops, I don't want to do it in red. I'm going to do it in black. And so what do we end up with? We end up with x minus 3y times 1. So that's just x minus 3y over. And then in our denominator, we have 1 times 1 times 1. Well, heck, that's just 1. So that means our expression in simplified form is x minus 3y.